in your notebook, you're writing graphing compound inequalities. That's what we're talking about, graphing compound inequalities. So if I asked you to choose, you have two options. One, you can take a 15-minute break and leave class 15 minutes early. Or you can take a 15-minute break or leave class early.
The same thing.
It's the same thing? No. You take breaks all the time. You're already taking a break. If I asked you if you had a choice, which one would you choose? Which one's the better option?
It doesn't matter. It's the same. Yeah, it's the same thing.
No,
They're
it's
the
not.
same?
Or leave 15 minutes early.
The first one. Obviously, the
first one's better. You stay.
First
The
one you
second
can
one
ignore.
do nothing for 30 minutes, pretty much. And then the second one, you could choose what to do for 15 minutes.
Yeah, so that word, there's one word different in both of them, right? The first one says 15-minute break and leave 15 minutes early. So that means you could rest for 15 minutes, you leave 15 minutes early, 30 minutes of your time is your choice, right? Whereas the other one says 15-minute break or leave 15 minutes early. So you could rest for 15 minutes, or you could leave 15 minutes early, but you're only getting 15 minutes of free time in the second one, right?
So you get both of them as well.
So the and gives us both, or only gives us one or the other, right? So we're going to be looking at, all the problems we're going to be looking at today are going to be either and problems or problems. Or, yeah, lots of ors. So when we go to solve and problems, or when we're graphing and problems, we want to make sure that our solutions, or what we're graphing, has to be true for both inequalities. So I can't graph something, I can't shade something in unless it's true for both inequalities. So we're only shading numbers that are true for both inequalities. It has to be true for both. If it's not true for both, then we can't use it. So an example of that's going to be something like x is greater than 5 and x is less than 10. So can you think of a number that's greater than 5 and less than 10? 6, 7, 8, 9, right? So any possible answer would be 6, 7, 8, 9. It's true for both of them. But I can't use numbers like 11 because even though 11 is bigger than 5, it's not smaller than 10. So 11 is not a solution because 11 is not smaller than 10. So it has to be true for both of them. We can only use numbers that are true for both. With an or inequality, it just has to be true for one of them. So we're shading all answers that make one inequality true. So the difference here is if I said, for example, x is less than negative 2 or x is greater than 3, it just has to make one of those true. Doesn't have to make them both true, it just has to make one true. So I could have things like negative 5 would be a solution because negative 5 is less than negative 2. I could also have things like regular 5 because 5 is greater than 3. So it only has to apply to one of them. So I could have negative 5, I could have negative 6, I could have 10. Smaller than negative 2, bigger than 3 are all good. If it doesn't make either of them true, then it's not a solution. Go away, box. What would be a number that's not a solution here? A number that's not smaller than negative 2 or bigger than 3.
Negative 10.
Negative 10 is smaller than negative 2, right?
1.
1.
Okay.
1, 2, 0, right? Those numbers in between aren't going to be answers. So examples of that would be like 0 or 1 here. Those numbers aren't true for either of them, right? 0 isn't smaller than negative 2, and it's not bigger than 3. So it doesn't work for either of them. So the biggest thing to remember here is that the ands have to be true for both. The ors just have to make one of them true.
So like you doesn't matter which one you choose.
So it doesn't matter which one for or, it doesn't matter which one you choose as long as it makes one of them true. If it doesn't make either true, then it can't be an answer. Ready to see some actual math with this?
No.
Pause right here. So I could give you things like I could ask you to graph x is greater than or equal to negative 6 and x is less than 3. So in order to graph this, the first thing I'm going to do is draw my number line. I draw my line. Now the difference from the last problems we were looking at and these problems are now I have two numbers that I'm working with. All my answers before, I just was putting one number right in the middle and then shading one side. These are going to have two numbers on them. So the first thing I'm going to do is I'm going to put the negative 6 on my number line and I'm going to put the 3 on my number line. I want to make sure I always put the smaller number first, just like I did on my number lines before. I kept them in order correctly. So I'm going to put negative 6. Now, if you're a very thorough person, feel free to count all the way until you get to 3 if you want to put all of those dashes in there. But personally, I like to save my hand from cramping, and I'm just going to skip some space and put a 3 on there.
So now you're just adding them together?
So now I'm just taking both numbers that they told me, and I'm putting those on my number line. Both numbers that are in my inequalities and my two separate inequalities, I'm using both numbers.
How do you figure out what the line goes?
So now, before I get to the line, first I'm going to do my circles. I'm going to look at x is greater than or equal to negative 6. And I'm going to say, what kind of circle do I need at negative 6? A closed circle, because it's an equal to. And then I'm going to look at 3 and say, okay, what kind of circle do I need at 3? Open. And then I'm going to go back and I'm going to look and I'm going to say, okay, when I'm at -6, I need numbers greater than -6, right? So if I was just shading a regular inequality here, I'd start going this way. Because I need numbers bigger than -6.
Well,
Yeah. But I also need numbers, they have to be smaller than 3. So,
-5, -4, -3.
yeah, so I need all these numbers in between. And see how if I kind of made little tiny arrows on purpose just to show me the general area that I was going.
So they intersect.
So they're going to meet each other, right? And I only can shade things that are the same. So I'm only shading in here. In between. The numbers that are in between. I can't, even though my arrow for my -6 was going to the right, I can't go past that 3. Because if I shade things like 4 and 5 and 6, those, right, those don't make the x is less than 3 true. Right? 4 is bigger than 3, it's not less than 3. So I can't shade those numbers. I have to stop once I'm not in a place that they're sharing. So I can only shade the things that overlap.
So it should be easy. That's all you gotta do.
That's all I gotta do for that one. So you try the other one.
I'll tell you right now. So you put the 4 on the number line, you put the 7 on the number line. That's open, so that both divide. So the 7 is a close circle for the 7, and it's going this way, and the 4 is going this way. You shade it that way.
So I put a closed circle. You just spoke faster than I can write.
I speak 18 different languages.
An open circle. My 4, I want numbers greater than 4, so I'm going this way. But my 7, I want numbers that are smaller than it. So again, I'm just shading in the middle.
Alright, I can do the worksheet. I feel extremely confident. Is that the lesson for today?
We are on example 1. Almost. There's 4 examples.
I do not think I need any more, but I will still.
All right. You can come along for the ride with us.
Alright.
All right. You're okay with this one?
Yeah, this is a lot easier than what we did before. It's literally just connecting 2 numbers. It's very, very.
So now I can ask you the same kind of thing, but you know how us mathematicians like to write as little as possible? So I can say exactly the same thing I was saying before without actually physically writing the and symbol. So what I have written here, the -5 is less than or equal to x and less than 2, is the same, it's saying the same thing as the first part of the example, it just has less words. So these are still and problems, they still have to be true for each other, but also notice, see how like the graphs that we drew, we shaded in the middle of them? We shaded in between the numbers. So all we did here is we want x to be in between -5 and 2. So it's almost, it looks crazier, but they're actually giving you the answer. Because they're telling you x has to be in between -5 and 2. So when I go to graph this, I put -5 on the number line. I put 2 on the number line. My -5 has a equal to sign. So I'm closing it in. My 2 has an open circle. And then I want the numbers in between them.
-4.
Yeah, I want everything, so I'm shading in here.
But it's going the opposite way though.
The sign, that sign with the -5 is pointing the opposite way, right?
Mm-hmm.
But remember how we said in order to use that, the x has to come first? So I can rewrite this part as x is greater than or equal to -5. And x is less than 2 if I wanted my x's to be first. But since I like to use as little words as possible or write as little symbols as possible, right? I like to just do it as quickly as I can. They're just showing you that that's another way that you can write your and inequalities. So you can write and inequalities as just like a string of things with the x in the middle.
Okay, if this question I'm about to ask, and I'm right, then I 100% know how to do this. So you're just finding, like, as soon as you get it, two numbers on the line, and you know the numbers in between, the middles, and whatever, you're just connecting them.
If it's an and problem for our ands.
These are all and problems.
These
right?
are all and problems.
So if it's like that, you know it's
And
and.
Yeah.
how, like, what is the or problem?
So, aha! Can you graph the other one? Put the 0 and the 3 in the number line, you go in between, right?
Less than. No.
Like this.
Less than or equal to.
Let's just make sure we can.
Yeah.
I put the 0, right? I put the 3, an open circle,
Close circle.
closed circle, and I'm
Yeah.
going in between.
That is 100% validation.
Cool. All right, so you're just so excited you want to see the or problems?
Yes.
So my or problems, I can only write one way. I can only write it as an inequality or another inequality. I can't smush it together. So anytime you see it smushed together like that, like the last one, you know that's an and. My or problems say things like x is less than or equal to -6 or x is greater than 3.
So the or problems are gonna say or.
They're literally going to say or, so you will know they're or problems. Isn't that nice for once in math? We're going straight forward.
It's easy. It's gonna tell me which ones are which.
So I'm putting the -6 on the line, and I'm putting the 3 on the line, just like I did with the and problems. I'm going to decide which circles I have. What do I have at -6?
Closed circle for -6.
What about 3?
Closed circle.
Now, for x is less than or equal to -6, I want to shade to the left, right? For x is greater than 3,
You wanna go to the right, right?
I want to go to the right.
Okay, so the ands are a lot easier. These aren't harder. They're just, you gotta think about them instead of just connecting them.
Right. And when we're talking about an or problem, we know it only has to be true for one of them. So once I decide which way I'm shading for one of them, I'm going all the way to the end for it.
So once you find out, so they're always gonna be opposites?
They don't always have to be opposites.
Oh.
Most of the time and most of the common problems, the ands will be in the middle and the ors will face outside, but there's always those weird situations where all of a sudden they might both be facing in the same direction. And I'm going to show you what that looks like. So normally my ors will face apart and my ands will be in between. How do you feel about the you do? X is greater than or equal to 4.
I put
Or-
4 and 0 on the number line.
Mm-hmm.
The,
Now, what do I put first on the number line?
0.
Yeah, good.
4. But you close the circle with 4.
Good.
And 4 is going to the right. 0 is going to the left.
Because I want numbers bigger than 4 and smaller than 0.
I feel extremely confident in this.
Yay!
I don't know about the rest of you, but I feel like this is a test. I 100% easy. Watch me get all of it wrong. If I was to get all of it wrong, I'm never. I can't say that.
So here are my weird situations. Here are the ones that don't really have too many real world applications. They don't really show up as often, but they are not impossible to get. So I just want to make sure you know what these look like. So my first one says x is less than or equal to 4 and x is greater than 5.
So 4 on the number line, 5 on the line, 4 is the closed circle, 5 is an open circle, and then 4 is going to the left and 5 is going to the right.
I agree with everything you just said, except what has to happen with an and?
They have to do the same way.
They have to share. I can only shade what they share, right? Are those two arrows ever going to overlap? No. No, did you catch that? Shh.
Wait, what was that?
So with an and, we said from the beginning, ands have to be true for both of them, right? They have to overlap. We can only shade what they share. Is there ever going to be a number that is smaller than 4 while also being bigger than 5?
That's an inequality. Wrong?
Can you tell me a number that's smaller than 4 and bigger than 5?
No.
No, it doesn't exist, right? There's no number that's smaller than 4 and bigger than 5. It's either smaller than 4 or bigger than 5. So because those don't share anything, this is a no solution. And that trips a lot of people up because you want to just go, okay, I see the I draw my circles, I do my arrows, I'm done. But my arrows don't share anything. That's an and problem, and I can't have shading on an and problem unless it's shared. So because it's going in opposite directions, it's an and, there's nothing they share, so there's no solution there.
So once you figure that out, like say for this one,
Mm-hmm.
You have to write no solution.
Yeah, so you would have to write no solution. You don't have to graph it at all. If you could look at that, if you read that and said, okay, x is less than or equal to 4 and greater than 5, you were like, wait, there's no number less than 4 and greater than 5. That doesn't make any sense. As soon as you read that, if you figured that out, you just tell me no solution. You don't have to graph it, but you do have to say no solution in order to get credit for that. Are you okay with that one? That's the weird one.
That one was weird, but it's not. It's like you just gotta think about it.
Yeah, you gotta think a little bit. So more or less, if you have an and it's going together, you're in a good place. If you have an or and they're going apart, you're in a good place. It's when you have an and that looks like a graph of an or you have an or that looks like a graph of an and, that you have weird situations. So the other one, the you do, says x is less than or equal to 2, or x is greater than -3. So when I graph this, I put a -3, I put a 2, my 2 is getting a closed circle, right? My 3 is getting an open circle. So I want numbers less than 2, right? So less than 2 is everything this way. Or I want numbers bigger than 3, -3. And I know with an or, it only has to be true for one of them. So even though it looks like it's going to be an and, right? It looks like they're pointing at each other. It doesn't matter because all of these numbers are bigger than -3. So I can shade all of them because they make x is greater than -3 true. I can also shade everything this way because all of these numbers are smaller than 2. So this has infinitely many solutions. So I can shade everything there because it's an or and they're like crisscrossing each other.
They look like ands.
Right. So if it's an and the graph looks like an or, it's no solution. But if it's an or with a graph of an and, then it's infinitely many solutions.
Is that it?
That's it.
Okay. I'm guessing the thing's gonna be on. Wait, are we gonna have a test on this?
We are going to solve compound inequalities on Monday. On Wednesday, you're going to take a quiz on compound inequalities. So the graphing and the solving.
Alright.
And then we have absolute value. Remember those bad boys?
No.
The ones with the lines in them?
They're not that bad.
We have absolute value inequalities to solve. And then you're going to have a test on all inequalities. So probably not next week, the week after.
2-3 weeks.
Like 2 weeks probably. 2 weeks. But you will have a quiz on compound inequalities with like the graphs and stuff in them.
How many more tests do you think we'll have?
Alright, okay, with your student lesson.
One more, because I believe the marking period ends the 4th. So that's like 2 weeks from now. All right.